Okay, good afternoon everyone. So today we are going to discuss about the next unit, the installation of solar PV system. Okay, sir, what is this installation of solar PV system? Already you are familiar about the different components that are used in an solar power plant. Now we are going to assemble all these components or we are going to connect all these components as an system. So this interconnection is called balance of system. Sir, why the name balance? So the concept of balance is each component may operate with some required amount of voltage and higher amount of voltage. So each component may operate with low voltage and one component require high voltage. Okay, so now we want to make all these components to be balanced. That is called balance of system. Okay, let's try to see each individual component step by step. So a solar PV system initially it requires a charge controller. Okay, already you are very clear from the previous session. Charge controller, the input is nothing but what? DC input, and this is going to take care about the overcharging as well as the over discharge. Okay, it prevents the system from overcharging. For example, you have a battery. Okay, so your charge controller will protect your battery from overcharging. So it will not make your battery to overcharge and it will not make your battery to over discharge. Indirectly the charge controller is going to protect the life of battery, so automatically the life of battery is going to increase. So that's what the main purpose of an charge controller. Next one, MPPT. The name itself it is very clear. MPPT, maximum power point tracking. What is this maximum power point tracking? So we have to track the maximum power from the solar panel. A solar panel, already we have been drawn the graph. So you are going to have the current, we are going to have the voltage. When you draw the MPPT curve, you are going to get only at one point you are going to get the maximum power. So the corresponding y-axis, the corresponding x-axis, this is called Vm and this is called Im, where this point is called as maximum power point tracking. Okay, so we are going to use an hardware to capture maximum current and to capture maximum voltage from the solar panel. That device is called maximum power point tracking device. Next one, battery. So from the previous sessions you are very clear that how a battery will store the charge in terms of watt hour. In the case of electric vehicle, it is represented in watt hour, and you have been studied about what is meant by an state of charge of a battery, what is meant by depth of discharge of an battery, what is the efficiency of an battery in terms of ampere hour, in terms of watt hour. So you are very clear about this battery. So now we have to assemble this charge controller, MPPT and battery. Coming to the next converter, which is called DC to DC converter. So for example, you require a solar. What is the input output of a solar panel? Fixed, I mean the what kind of DC you are going to get. So this is an fixed DC, but when you want to convert into a required AC, we need to convert the DC to variable AC. Then we need to study about DC to DC converters. Okay, so these are again 6 types. So class A chopper, class B chopper, class C, class D and class E chopper. So generally we will call it as a step down chopper, step up chopper. Next one, step up and down, which is called buck boost converters. Okay, so all those choppers we use and we will try to convert a fixed DC to variable DC. This is required when you want to control the required voltage and current. Next one, you are very clear that the input, I mean the output of a solar panel is DC input, but you require an AC load is there. So then you need to convert this DC to AC. So that is possible with a normal inverter, which is called as a multi-level inverter. Okay, so you know the importance of this level. So if more levels are available, the waveform is purely sinusoidal waveform. Okay, you have this number of ways of converting the DC supply to AC supply with the help of an sinusoidal pulse width modulation techniques are there. Okay, by using the sinusoidal pulse width modulation techniques and different modulation techniques, you can convert the given DC supply into an which supply? AC supply. So or directly a step type of input also you can convert into an AC supply, which is also possible with a multi-level inverters. Okay, more R&D is going on in multi-level inverters. So here what kind of inverter we are using? What is the name of this inverter? So these inverters are called grid connected inverters. Okay, these inverters are called grid connected inverters. Next one. So you are very clear about this solar panel, how to connect the solar panels in series connection, how to connect the solar panels in series connection to make as an array, how to connect the solar panels in parallel connection to make as an array, how to connect the solar panels of same rating, how to connect the solar panels of different rating, and what are the problems associated in it. So you are very clear about this solar PV panels. Next type of device is protective devices. Okay, so basically we use HRC fuse. So what is HRC fuse means? High rupture capacity fuses. Okay, this is like a normal fuse. So if this will be like a box type fuse, so this will be like this. So it is filled with some sort of material, and they seems to be like a small box, and these fuses are called as a high rupture capacity fuses. Okay, so already I told we are going to join this solar panel either in series connection or in parallel connection. For example, I have been joined solar panel 1, solar panel 2, solar panel 3 in series connection. The resultantly will be given input to the HRG fuse, and this will be connected to the load. Okay, so your HRC fuse will be connected in series to the array. So it protects from over currents. Okay, or it protects from whenever short circuits is going to occur. The latest are nothing but the relays. Okay, the next one, we are very clear that so sometimes we need to convert AC may be available. For example, you require a DC load, but you have an input as AC load, then you need to convert from AC to DC with the help of inverters. So overall, all these components are known to you. You are going to integrate all these components, or you are going to join all those components. So joining all those components together is called as balance of system. Okay, so on our average, you know in detail about all these components. Okay, so what are the different components involved in the solar PV system? First one is charge controller, next one is maximum power point tracking device, next one battery. So you can connect the batteries in series connection or in parallel connection. Next one, DC to DC converters. So you have class A, class B, class C, class D. So generally they are called as a step down, step up, buck boost converters also. Next you need to convert DC supply to AC. We generally use a multi-level inverters. So, and you are very clear about in the previous units, you are very clear about how to connect the solar panels in series and parallel connection. So the output of the series, for example, this is solar panel 1, solar panel 2, all three are there. So here you are going to connect an HRC fuse, and HRC fuse and the output of, HRC fuse is connected in series to the solar array, which protects from short circuits. So the latest you can use the relays also. Okay, generally when you join the solar panel at positive and negative, so through HRC fuse will make the positive to flow, which protects from short circuit. Okay, when your short circuit occurs or when positive and negative touches your solar panel due to any other events, automatically this HRC fuse will help you. So next device is AC to DC. So all these are assembled in our solar plant where this technique is called balance of system. Okay, now coming to the basically what is meant by a power converter. So power converter means this includes rectifier, this includes DC to DC converters, and this include inverters. Okay, all group is called as a power converter. What is the purpose of a converter? So input is low current, output is higher voltage. For example, or it may convert the output as low voltage and high current. It depends upon the type of action. So for example, you are given a DC. So DC to DC, they are called as what? DC to DC choppers. Okay, so for example, AC input is given, output is what? DC. So input is AC, output is DC. These are called as rectifiers. So sometimes you may give DC input and you may require AC output. Then they are called as multi-level inverters. Okay, so every converter will perform the same action. Okay, so they will change the voltage level as well as current level. Automatically the power level is also increased or decreased as per the requirement of the load. So what this IGBT or what this power electronic devices do is they consume the power for the energy conversion. So sometimes, for example, it's an boost converter. What a boost converter will do? It will boost. So boost means it will boost up the output. Okay, so it will give an high power output, but input is low power. So the voltage and current product, input power is lower but output power is greater, so those converters are called boost. So it perform its action. So next one, and you can see here all these are power electronic devices. Generally they will create a loss of 5 to 25%. These losses are called switching loss. Okay, you have to give the gate pulse and they have to activate and they will create some sort of power loss, approximately 5% of loss. The more latest power electronic switching is IGBT, generally we use. Now we need to link the input and output power. So input power is equal to output power plus losses. For example, input have been given 100 watts. How much input power had been given? 100 watts. The output power may be 90 watts and it creates a loss of how much? 10 watts. So I can link this input and output by the formula. Input power is equal to output power plus losses. So now similarly I want to calculate the efficiency of an converter. So keep it in the mind, converter means it may be a rectifier or it may be an inverter or it may be an DC to DC converter, anything, the concept is same. So the efficiency of a converter is defined as the output power divided by input power multiplied by 100. So what is the output power? So depending upon the converter, the output power may be changing. For example, if it is an efficiency of an inverter, what is the output? AC output. What is the input? DC input. So based upon that, the efficiency is going to change. So generally the efficiency of a converter ranges from 75% to 90%. All inverters will have minimum 90% of efficiency. Okay, this is how to calculate the efficiency of an inverter. We'll try to solve some problems. Based on that, you can calculate the efficiency of the converter. Okay, all these are called as the balance of system. Okay, so now let's try to solve some problems to make how to understand about these power converters.